Hi ladies and gentlemen, this is Ms. Skokin. We're going to be taking a look at the third type of transformation, that is an isometry, and that type is rotations. Our objective is to identify and draw rotations, our vocabulary is rotations, and our essential question is how are transformations used in art, architecture, and industry? So let's start by taking a look at our warm-up questions. Question number 1 says the translation image of P, which is located at -3, -1, is P prime at 1, 3. So we want to find the translation image of point Q. So pause the video and turn it back on when you've figured it out. When we take a look at the comparison between the pre-image and the image for point P, we see that the x-coordinate and the y-coordinate were both increased by 4 to get the image value. And if we do that same transformation or translation to point Q, we end up getting an image of point Q, Q prime, located at 6, 0. All right, for questions number 2 and 3, there is a mistake in your note, so I'd like for you to look around the room that you're in right now and write down an example of a reflection for number 2 and of a translation that you see around you. Turn the video back on when you have completed number 2 and number 3. So my example of a reflection is the letter M that I see written on a poster, capital M, and it can be seen as the two halves that are reflected over a vertical line to create the letter capital M. And for number 3, the stars on the American flag are 49 translations in either the vertical, the horizontal, or both directions. Make sure your examples are not the same as my examples for when you turn in your work. I'd like for you to think it through and come up with an original example. All right, let's move forward. The third type of isometry that we're going to learn about is a rotation, and a rotation is a transformation that turns a figure around a fixed point, and we call that point the center of rotation. A rotation is an isometry. It does not change the size or the shape of the figure, so the image is congruent to the pre-image. We take a look at example 1, which is identifying rotations, and in example A, it definitely does not look like our red figure turned or rotated in order to become or take the place of the blue figure. It actually, what it looks like is a reflection, because we see the mirror image from one side and the other across that vertical line of reflection. So we're going to say this one is not a rotation, and it is a reflection. When it comes to question B, we can see the shape. It's kind of like a C shape. It's not quite a half circle or a donut, half of a donut, but we can see that there seems to be this point around which the blue figure rotated to become the red figure, or vice versa. So we can see if we say we're starting out with the blue one, it looks like it rotated in the clockwise direction to become the red figure. So that one is a rotation. When we have rotations in the coordinate plane, we have specific rules, mapping rules that will be followed. If we are rotating by 90 degrees and we're using the origin as that center of rotation, then our mapping rule will be the x-coordinate, the new x-coordinate, is going to be the opposite of the old y-coordinate. And the new y-coordinate is going to be the old x-coordinate. When we're rotating by 180 degrees about the origin, this is kind of intuitive because we know our points are going to end up in the opposite quadrant from wherever they started out. So whatever your original points were, x maps to negative x, and y maps to negative y. Whatever it was, it's going to be the opposite coordinate. Again, this is intuitive because we know it's going to end up in the opposite quadrant from wherever it started out if we rotate by 180 degrees about the origin. If the angle of rotation in the coordinate plane is not a multiple of 90 degrees, we can use sine and cosine ratios to find the coordinates of the image. Now, this is something that we haven't learned yet, so we're going to pick this up later on in the year. Let's take a look at example 3 now. In example 3, we want to be able to draw rotations in the coordinate plane. We're going to rotate triangle ABC with vertices A, B, and C by 90 degrees about the origin. Let's start by writing down our pre-image coordinates. Next, we need to take a look at the rotation rule that we just learned in the box, and the rotation rule said that xy will map to negative y comma x. And that's going to be the same rule for the 3 points. And that means that we're able to figure out what the coordinates of the image are. So they're going to be called A prime, B prime, and C prime. And then we're going to use that rotation rule. So the original y, which was -1, we're going to use the opposite of that as the x-coordinate. So our x-coordinate is going to be 1. The original x is going to be the y-coordinate, so that's going to be 2. For point B, the original y is going to be the opposite and is going to be the new x. So we had 1, now it's going to be -1 as the x-coordinate. And we use the old x-coordinate as the new y-coordinate. And same thing for point C. So now we've got our image coordinates. And we would be able to graph both our pre-image and our image, labeling all the points, and we would see that rotation by 90 degrees in the counterclockwise direction about the origin. Typically, the direction that we do rotations in is counterclockwise. Sometimes we're going to see what looks like a backwards rotation because it goes in the clockwise direction. But most of the time we're going to be seeing the angle of rotation go in the counterclockwise direction, or what looks like that direction. All right, let's take a look at the next example. We want to rotate triangle JKL with the vertices given to us by 180 degrees about the origin. So once again, we're going to begin by writing down our pre-image coordinates. The next thing that we need is our rotation rule, and if you remember, we said that both the x and the y coordinate are going to go negative because we're changing from one quadrant to the opposite quadrant when we rotate 180 degrees. And our rotation rule then is x comma y maps to -x comma -y. So it's going to be really easy for us to come up with our image coordinates. J prime is going to be located at -2 comma -2. K prime is going to be located at -4 comma 5. And L prime is going to be located at 1 comma -6. Now again, ideally we're graphing these, but we don't have a grid, so just remember when you do these practice problems at the end of this lesson, which is coming up in just a second, you're going to need to graph your rotations. That means the pre-image and the image, labeling the points and labeling which one is the pre-image and which one is the image. All right, that is it for this lesson, and it's time to practice the new skills you've learned. See you back in class.